Is Karahan. He'll be presenting BUTID, a large-scale sign language translation dataset and benchmarks for Turkish sign language. Let's give him a big applause, please.
Thank you. I'm Karahan. I'm a research assistant in CBSSB, also a former master's student in Boğaziçi University, which I did this research. I want to thank two organizers to put me in this hour after Matt, because we did everything Matt advised us not to do. but we didn't know before, But we try to address different problems in the literature with this research. So we call this dataset BUTID. It is a first large-scale dataset for Turkish Sign Language translation. So this is our dataset that we collected from internet, but it's the data content from national broadcast television, mostly containing soap operas, but also including news, signed news, and some documentaries. And we have collected 500 hours of data with automatically aligned sequences, more than 256,000. As we said, data is coming from YouTube. We did open source data collection, but for the anonymity purposes and copyright purposes, we only included the signed content in the sequence where we got the consent of the actual interpreters in the sequence, and we only shared the transcriptions alongside with the content. So, as you can see, this is the 6th largest dataset provided in overall translation literature, and it's the 4th largest monolingual one, and it's the largest one for Turkish Sign Language. We created 2 subsets, as we call single caption and multi-caption. These datasets only change depending on its collection strategy, but we use the same alignment strategy, which I will explain in a minute. So we identify these sequences as single caption because this is the only one sequence, one segment that is transcripted, but in the other, we try to merge sequences with almost little to none conversational gaps in between. So the interpreted content is much longer than a regular transcript. So we created these 2 subsets to evaluate. And our alignment is a bit different than the rest because we try to use natural conversational gaps in the actual content, where we see a padding before and after the sequences. So we try to find where the sequence is actively signed without overlapping with other content. So we target these sequences with an additional end offset to give interpreters additional time. And finally, we extract pause and find where the sequence is actively signed. With this, we use a standard benchmark given in YouTube ASL research, a benchmarking strategy where we project the pause input with a projection layer to the token space of an LLM. And we use MT5 model to benchmark this. And we also added additional strategies for augmentation in both text and sign level. In the sign level, we do some sampling strategies where we drop some frames or do cue masking to mask hands. In the paraphrasing, which I will talk in more depth in a minute, where we use it as both an augmentation strategy as well as reference generation because of the structure of Turkish language. For this, we fine-tuned a pre-trained language model, which is specifically trained on Turkish language, and we fine-tune it on paraphrasing dataset. With this, in this table, we report the augmentations only on sign, and we report the classical metrics with blue, rouge, and BERT score. This is, we only report BERT score because blue RT is not available for Turkish language, but we all needed a semantic metric to report our translation performance. So for the single caption setting, we see a lower blue 4 score because we have a very limited context length, as well as the structural difference of Turkish language when we compare it to English, which I will show an example in a minute. And we see that for these short sequences, sign level augmentation adds some noise to our sequences because I think our sampling is much faster when we compare to other data sets. For the multi-caption, we see a larger blue 4 because we have a much longer context. And when we apply paraphrasing as an augmentation, we see a huge increase in comparatively significant increase and improvement to blue 4 score. While we cannot apply this because our trained model does not large context as our multi-caption dataset. So why do we have such low scores for Turkish language? We distinguish Turkish as an agglutinative language and English as an isolating language, meaning for a sentence like he is one of the people who is not able to come, we have only one word for it, gelemeyeceklerdenmiş. And for he was one of the people who was not able to come, we also have one word, gelemeyeceklerdendi. Only difference being the morphological marker at the end of the sequence. So while the difference, the similarity of blue 4 is 0.87, we have a blue 4 of 0. So our metrics are heavily affected by this. And here we can also see in these examples, even though most of the words are similar, we see a blue 4 of 0 because of the word order. And since we have morphologically rich language, we have sentences and segments less than 3 words or 2 words. So our 4 token alignment would be affected also from this. And we don't have only the morphology difference, we also have word order difference. We can shuffle the word order in Turkish, so which would also affect the 4 gram match. And finally, as I said, because of the morphology, our blue 1 score is affected from this as well. So thank you for listening. And do you have any questions? Okay.
Have you checked the ablation on how much the alignment helps your translation?
Sorry?
Have you done an ablation on how much the automatic alignment helps your translation task?
So we only use the automatically aligned sequences, not the original subtitles. So there's not an ablation for this. But to add this, we have more than, sorry, this is disconnected. So we have more than 2,000 hours of raw footage if we use fully automatically aligned data. So we can ablate this in the future. Okay. One more question? Yeah. No.
Hello, my name is Chanda. I just wanted to ask you a quick question. Will the Turkish deaf community be missing out information from InVision interpreters or films because they may not understand the written language and they prefer to use the visual interpreters on the screen? Because AI will help them. Turkish friends have told me that with films they don't often understand the subtitles and they prefer to use an InVision interpreter for that.
Yeah, definitely. And we yeah, thank you for adding this part. We also, because of the copyrights, we don't have the movie content available for us, but we hope to use this data set in the future for additional translation purposes for those content that is not available. I guess that's, yeah, thank you.
Let's give him a big applause once again, please.